Alrighty, this is going on page 38 when we are done. So in this picture here, do I have a line segment? Yes. Do I have rays? Yes. Do I have points? Yes. Is this a line? Yes. All that stuff is happening here, right? And depending on how we talk about it and how we name it, that's what changes what's what here. So we're going to look at these 2 points, and I'm going to name these A and B. And I know that since they are capital, these are the names of the points. And then I'm also going to put a lowercase a and a lowercase b on the points, which is not wrong, it's just not their names. Okay, so the capital ones are the names. That is point A and point B, talking about the picture itself. The lowercase ones are the coordinates of the points, which means they represent numbers. So the capital ones represent pictures, the point itself, and the lowercase one represents the numbers. So it could be an ordered pair if it's a two-dimensional coordinate, or it could just be a number if it's like on a number line. All right, so lowercase is numbers, capitals is the pictures. So we can write this stuff out a few different ways. If I have this, I want you to think without speaking about how you would say that. Like, that's how you write it, that's what you see, what would come out of your mouth. All right. Catherine, how do I say this? Line AB. Y'all agree? Yes? Okay. So I'm going to put that in quotes since that's what's coming out of our mouth. Line AB. Thank you, Catherine. All right. And then I have this. I want to know how to say that. Rigoberto. Where are you? All right, how do I say that? Line segment AB. Thank you. So this is line segment AB. So both of these things refer to figures. They refer to two different figures, right? And then if I have this with nothing above it, that is not a list of points. If it was, it would say, literally say like A and B, or there'd be a comma there. But there's nothing there. What this means, this actually means, it's a whole lot more worded than the other stuff when you have something above it. This is the length of line segment AB. And it represents a number. Okay? So I can put AB equals 5. That would mean the length of line segment AB equals 5. A segment and a line can't equal a number. That doesn't make any sense. Segments are pictures or figures, and then values are your numbers and other things. Okay? Everybody good so far? Because remember, none of this is crazy hard. It's just that you got to keep up in your mind with what the different things mean. Because this thing right here, you're going to see this kind of thing, or you see all this all year long. And so if I say find line segment AB and it looks like this, then you can point to a picture. There's line segment AB. If I say find this doesn't mean find the line segment, and don't come to me and say, I don't know what this means and what I'm supposed to do, because I'm not going to tell you, because I'm telling you right now. This says find the length of line segment AB. That means you're looking for a number to find. Okay? We good? All right. So let's look at this number line. We're going to go through the number line kind of quickly together here. So using the number line above, find the distance between. So we're going to start with B and D. What would be the easiest way for me to find this distance? Count. So 1, 2, 3, 4, 5. Right? Distance is 5. Distance between A and B. So that is 1, 2, 3. Right? Easy enough? So we found these by counting. Now, what if I wanted the distance between 5,872,000 and 283? Do you want to count? Subtract. Okay, so if I take negative 5 minus a negative 2, what does that give me? It doesn't give me 3. It gives me negative 3. Okay? Negative 5 minus a negative 2 gives me a negative 3. Can you have a negative distance? No. Okay, so what could I do mathematically to make it be what I really want? Yes, sir? Thank you. That's the second time today. Usually I can't get those words out of you, and when we finally do talk about whatever makes it positive, that doesn't really happen. So thank you. Absolute value. Yes. Because you can't really state what order to subtract in. Because think about this. If I did -2 minus a -5, what does that give me? Whew. -2 minus a -5 is -2 plus 5, which is 3. So if I subtract that way, I get 3, and it's fine. If I subtract the other way, I get -3. But if I take the absolute value, it doesn't matter what order I subtracted, and I don't have to keep up with that stuff. All right? So absolute value. That is exactly it. So this says, given two points, A and B on a number line, the length of line segment AB is this. That means the length of line segment AB. And it's equal to the absolute value of little a minus little b, because those represent the numbers on which they are on the number line. Okay? Where little a is the coordinate of A and little b is the coordinate of B. We're going to do it. That's a very good question. All right, so we're going to find the length of line segment BC, because that's what that means right here, right? So the length of line segment BC equals the absolute value of B minus C. Okay, so the coordinate of B is -12. The coordinate of C, so I do minus a -5, like that. Okay, so minus a negative means it becomes plus a positive. So that gives me the absolute value of -7, which is 7, and that is the length of BC. Okay? Everybody okay with that? What if that was a +7 in here? Would this be a -7? No, because the absolute value, it's the distance from 0. That's all it really means. That's why it's the absolute value. It's actual like a distance. It's not a, none of them come out negative. We all good? Absolute value shouldn't be a new concept for you. So let's go ahead and do the next one together just so we can spend more time on the other stuff. We're going to skip B. All right, so C says find the length of QS. So QS, the length of QS is equal to the absolute value of little q minus little s. And it tells me that the coordinates of Q is -3 minus the coordinate of S, which is 21. Okay, now, we really shouldn't have any trouble adding and subtracting positive and negative integers, but depending on how you think about this, I'm already at -3 on the number line, then I've got to go to the left 21 more, so that should kind of help you. But the reason here you get to do plus a positive is because really you can always change subtraction to addition. All you do is change it to addition and change the sign on the number. So I can change this to plus a -21 if that helps it make more sense in your head, because then you're adding two numbers with the same sign, which means you add the number and keep the sign. So this gives me the absolute value of -24, which gives me what? 24. And that is QS, the length of QS. And whether you have 24 equals the length of QS or the length of QS equals 24, it doesn't matter. That's less writing because then you just write on the end and box it. Whatever works. Everybody good? Okay, awesome. All right. So betweenness, right? So you should have a good concept of what the word between means, right? Remind me of your name. Eric? Cameron? Okay. So if I was to say that Cameron is sitting between Elijah and Eric, would y'all agree with me? Like he's sitting between them, right? Okay, so just like when we talked about curvy lines, which I can say draw a squiggly line or a curvy line, mathematically that doesn't make sense. Mathematically he is not between the two of them, right? He is when, sitting in the classroom, but mathematically he's not, because between this says it says point M is between points P and Q. So Cameron is between Elijah and Eric if and only if P, Q, and M are collinear. Okay? So if I said that Cameron is between Elijah and Eric, that would mean that the three of them are collinear, which right now they are not. Okay? So it has more to do with just being like literally in between like we think of. It tells you mathematically that they have to be collinear. Okay? We good? So if we draw that, so we've got P and Q. Here's P and Q. They exist together on some line or line segment. So M is between them. I don't know where between, but it is between them somewhere. So here's M. Right. That's what the betweenness means. They've got to be collinear. And then if that's true, whatever the length of PM is, plus whatever the length of MQ is, what do you think that has to equal? The length of PQ, right? And that kind of makes sense. This piece plus this piece equals the whole thing. That's all that's saying. Okay. Everybody okay with all that? All right, so then we have the segment addition postulate, which is going to sound kind of repetitive of what we just talked about. But first, I want to know what a postulate is. I want to know what is a postulate from Xavier. Where are you? Okay, very good. So it's something we can't be proven or can't be denied or disproven. We just accept it as fact, right? Okay. So this is one of them. Like, there's really nothing else that would make sense, but it is what it is, and we just can't prove it. So this says if 3 points, A, B, and C, are collinear. Now, if that's all I told you was, hey, they're collinear, do you know what order they're in? No. So it says they're collinear and B is between A and C. So actually saying that it's collinear is kind of redundant. Really all I had to say was that it's between because that implies collinear. But now I know that B is in between them. I still don't really know which one comes first, but that doesn't really matter. But B is between A and C. So let's go ahead and draw that. Here's A, here's C, here's B. Now remember, mathematically, you have to have a rule for everything you do. So you've probably actually used this postulate before, but didn't even know it was a rule or that you had to have a rule. Because what this says is what we already really wrote down for betweenness, that if the length of AB, if I have the length of AB, and I add it to the length of BC, what does it have to equal? AC. So it's this piece plus this piece equals the whole thing. It's easy, it's obvious, but that's the rule that allows us to set up what we need to set up to solve things. Okay, we good? Remember, be thankful that postulates usually make sense. Segment addition postulate is exactly what it sounds like. You're adding segments together, right? But do you actually get to add segments? You're adding what? The lengths of the segments. Okay, you can't add pictures, but you can add numbers. So we're adding the lengths of the segments is what's happening. All right, so let's look at this example. It says if S is between D and T, find the length of DS and the length of ST. So the first thing you should do after reading the question is draw a picture. Now, do you have any idea at this point how long this segment is? No. Do you really even know which point is on the far left? No. Does any of that really matter? No, because you're just drawing something to be able to label it. So it says S is between D and T. So here's line segment DT. I don't know where S is in between this anyway, right? So somewhere here, so I have enough to label. So there we go. S is between D and T. Find the length of DS and length of ST. Then we have all this stuff over here that we need to label. It says the length of DS is 2x minus 8. The length of DT, this whole thing is 60. And the length of ST is 3x plus 12. Okay. Now, is S right in the middle of D and T? No. Could it be? Yes, but we have no way to know for sure, right? Even in my picture, it kind of looks like it is, but I drew it, so it doesn't mean, usually when it's supposed to be, it doesn't look like it does. But, so these two might have the same length, but I don't know that. No, there's nothing that tells me that right now, so I don't want to start off by just setting those equal to each other, because that wouldn't make any sense, right? But I do have the segment addition postulate that says this piece plus this piece equals the whole thing, right? So is that something I can set up to solve for x? Yeah. Did anybody ask me for x? No. But I've got to find it to find what I want, right? Because I can't say that my answer for ds is 2x minus 8 and the answer for st is 3x plus 12, because then this would be like the dumbest question on the face of the earth, right? So I have to actually find some stuff. So I know then from the segment addition postulate that the length of ds plus the length of st equals the length of dt. At this point, I am 100% done with the geometry. The geometry of this is applying the segment addition postulate. Bam, we just did. 100% of the rest of it is just arithmetic and algebra. Because now that I know that this is true, I'm allowed to write this because of the segment addition postulate. These all have to represent numbers, which so do these up here, so I can replace things with what I have in green. What's my mathematical word for replacing things? Substitution. So I'm going to substitute. For ds, I'm going to substitute in 2x minus 8. For st, I'm going to substitute in 3x plus 12. And for dt, I'm substituting in 60. First step, zero work, you just write it down. Okay? You just plug stuff in, you substitute it in, write down what you have. I realize that these are not that hard of numbers and that you could totally combine things as you write them down. Don't do that. Okay, that's gonna lead you in some bad directions sometimes. Plus, this shows process. This shows the actual application. If you had to do a proof, which you're not right now, which you always kind of have to be thinking that way, is that my reason for this would be segment addition postulate. And then my next step would be this, and my reason I get to do that is the substitution property of equality. Right? Then I get to combine things. I don't get to do them at the same time. Does that make sense? So then after you've plugged it in, then you can skip some steps. But you got to get that important, where the heck is this coming from, and show me process part of that. Okay, so now I've just got to solve for x. So this, I know this is going to give me 5x plus 4 equals 60. So 5x equals what? 56. So x equals... Now, do I want a decimal? No. Do I want a mixed number? No. Does it divide evenly? No. Then what does x equal? 56 over 5. And you stop. If I wanted a decimal or a mixed number, that requires more work. Stopping requires less work. So you just stop. You reduce if you can, but you can't reduce at all. So that's x. Am I done? Can I move on to the next one? No, because nobody asked me for x, right? Make sure you're answering the question that's being asked, but also make sure that you're not doing too much. Sometimes maybe you are just asked for x, so you don't need to go plug it back in. But here I need to. I'm looking for the length of ds and the length of st. So ds is equal to 2 times 56 over 5 minus 8. So I need to multiply 2 times that fraction. Multiplying fractions, easy? Yes. You can just think of this as being over 1. You can just multiply straight across. So what's 2 times 56? 112 over 5 minus 8. Now can I reduce the 112 over 5? No. So I have to subtract these. So what do I need to get? Common denominator. So the denominator on the 8 right now is a 1. What is the common denominator going to be? 5. So 8 over 1 becomes 40 over 5. Which means then that I get, what's 112 minus 40? 72. So I get 72 over 5. Can I reduce that? Nope. So that is the length of ds. Any questions about that? Okay, so now I have to find st. I have two options. I can substitute it in, or I could take 60 and subtract the length of ds, and then I could get st. Would you agree with that? Okay, but here's the thing. Let's say that ds was wrong. I messed it up, right? I got 73 over 5 or something. And then when I subtract, do I have any hope of getting st correct? None at all, right? So, but if I substitute it in, like let's say ds is wrong, if I substitute it into st and I do that work correctly, I at least have half of it right. Okay, so that's a little bit safer to go ahead and do that. So we're going to do 3, let's see, what do I do? Length of st is equal to 3 times 56 over 5 plus 12. Okay, so the 3 times 56, let's break it up. What's 3 times 50? 150. What's 3 times 6? 18. 150 and 18 is 168. You see how easy that is? So this gives me 168 over 5 plus 12. So I can't reduce that, right? So I've got to get a common denominator, which is going to be, what? 5. So this becomes 60 over 5. So 168 plus 60, 228, 28 over 5. Can I reduce that? Nope, that's the length of st. And I have found the two things that I was asked to find. If I add those two answers together, what should I get? 60, right? So what is 72 plus 228? 300. And 300 divided by 5 is 60. So there you go. You just checked yourself without actually checking yourself. Okay? Any questions? Good? Okay. The fractions part on that test was like super scary for on some tests. Like some of y'all are just making stuff up. Some of y'all had no clue. This is like 3rd and 4th grade math. You've got to have these skills, or you will you'll struggle through here, and then you won't make it through algebra 2 because the calculator won't even help you there. All right, let's look at this one. We're going to go ahead and do this one together too, so that we can make it through the rest. E is between D and F. So here's D and F, and then here's E. All right, so then I'm going to label. I've got DE is 3x minus 1. EF is 13, and the length of DF is 6x. And remember, even if you think that it's stupid to draw the picture and you don't need to draw the picture, that your opinion doesn't matter. My opinion doesn't matter, right? This is just how the problem is. You're supposed to draw and label your picture. This is what we do. Because if you don't, then there would be definitely some people that would try and model the one right above it and then try and add 3x minus 1 plus 6x and set it equal to 13, because that's kind of the pattern that was above it, but that didn't make any sense. Adding these two up and setting them equal to 13, when it's in front of you, that makes absolutely no sense, hopefully, anyway. So, again, E is between these two, so I know by the segment addition postulate, this piece plus this piece equals the whole thing. So 3x minus 1 plus 13 equals 6x. That is the end of the geometry. Actually, that kind of skips the technical geometry part of it because we just jumped right to the substitution part. But the setup, that's it. The geometry rules are tell you how to set up. The rest is 100% algebra. So this is 3x plus 12 equals 6x. Now, I could move the 6x, but it's safer not to, right? So this is going to give me 12 equals 3x. So x equals 4. And that should be a piece of cake for you. All right, so then I go and plug this in, substitute. Now, I don't have to substitute it into both of these. Read the question, right? And they didn't ask me for x, but I had to find it. It only asks me for df, so I only have to plug it into that one. So the length of df is equal to 6 times 4. What's 6 times 4? 24. That is the length of df, and you are done. Any questions at all? Good? All right. A couple more definitions. Terminology is huge in geometry. All right, so two segments with the same length. Well, what is, if something has this, two things have the same size and shape, what's the word for that? Congruent for the segments. That would be, equivalent would be dealing with numbers, okay, like equality. But when they are pictures and they're the same size and shape, I heard it over here, they are congruent. That should not be a new word for you. The symbol for congruent is the squiggly with the equal sign underneath it. Very rarely do I write out the word congruent because we can abbreviate with the sign. Technically, the symbol means is congruent to, but we will just use it for the word congruent when we're writing so we can write less. Okay? So two segments with the same length are congruent. Figures are congruent. Numbers and values are equal. Okay? Two segments cannot be equal to each other. That doesn't make any sense. Two values can't be congruent to each other. That doesn't make any sense. Right? But if I have, so let me draw my segments, AB and CD, and I have no idea how long these are, but I do know that they are the same length at least, which means that they're congruent. So if I can't put a number on there because I don't know how long they are, how do I make that picture obvious that they're congruent without putting any numbers or saying anything else? Right, but I want to write anything else. I just want to put something on the picture. Well, but I wouldn't put this and then like put the congruent sign. It's something I actually draw on the picture. Okay, you could make it, she said make it a parallelogram. But when you do that, that just makes them parallel. Does that make sense? So even though technically the opposite sides of a parallelogram are congruent, but the signs that you've seen with them written there, that doesn't actually mean congruent. The little hash marks like that. Okay, that means they're congruent. If I have a second set, then these would each have 2 little hash marks on them. Okay, so that right there, I have no idea what length they are. I do know that they're the same length though, and that they're congruent. That's what that means right there. Okay, so to write out that is line segment AB is congruent to line segment CD. So 2 line segments can be congruent to each other. They have the same measure, so their measures are equal. That would look like this. The length of AB equals the length of CD. But making this an equal sign or this a congruent sign does not make any sense at all. And that's something that I'm going to have to kind of correct you on quite a bit at the beginning, making sure that we're saying this stuff correctly. Okay, we all good? All right. So then, next definition, the midpoint. The midpoint M. Now, midpoint doesn't always have to be the letter M. It's just, it is in this case. The midpoint M of line segment AB is the point that bisects or divides the segment into 2 congruent segments. Okay, a bicycle has how many wheels? 2. That's why it's a bicycle, right? This refers to like sections, so basically 2 sections, but it's not just 2 sections. If you're going to share a candy bar with me, I want you to bisect it, not just to divide it into 2 sections because you might get more. But if you bisect it, then it divides the segment into 2 congruent segments. Okay, so it's not just about being 2 pieces. The 2 pieces that you get are congruent to each other. Okay? So if I do this, if all you had was the picture, like you don't have any of the words or anything, this is all I gave you. And I said, is M the midpoint? Is it? How do you know? How do you know it's bisected? How do you know it's the middle? Yeah, you don't. If this is all I give you, just because it's an M and just because it looks like it's in the middle, doesn't mean that it is. And just because it doesn't look like in the middle doesn't mean that it isn't, right? But if I want you to be able to look at this picture and just know, yes, M is the midpoint, then I have to do this. Now you know for sure. Don't assume anything. Assuming stuff in geometry, it can get you in a lot of trouble. And I know that there are some things that y'all were kind of trained to assume, and it drives me insane, and I have to undo all of that because it's wrong, 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 and bad, bad, bad. Okay, so we assume nothing. If you're not told something or it's not labeled or you don't have the information, you can't assume it. Okay, so sometimes the best answer you can give is we don't know. Maybe. Could be the midpoint, but I'm not sure. But with that, I know for sure that has to be the midpoint. Does that make sense to you? Okay, so that means in this picture here, what's happening is the length of line segment AM is congruent to line segment MB. Okay, so third definition is of a segment bisector. Okay, a segment bisector. It is any ray, segment, or line that technically doesn't bisect the segment, but if it's going to do what you think it is, bisect the segment, where do you think it's going to have to intersect the segment at? The midpoint, right? So a segment bisector is any ray, segment, or line that intersects a segment at its midpoint. Technically, it's the midpoint that does the bisecting, and then those other things just intersect at that midpoint. So I want you to draw 3 segments, like this, and then we're going to name them all the same. D. So just make 3 segments that look like that. So M is the midpoint of all of those. And a segment bisector can be a ray, a segment, or a line that intersects at that point. So I could have a ray that looks like this. This ray is the segment bisector of line segment AB. I could have a segment like this. Now, in this picture here, the orange segment is a segment bisector. The green one isn't necessarily. So the orange one bisects the green one. The green one doesn't necessarily bisect the orange one. It could. They could bisect each other, but that's not always a given. Okay? So make sure that you're paying attention to which parts you actually know are congruent, and don't just think because they cross, they're going to cut each other in half. Okay? We're good? And then you could have a line. Ooh, that is not even straight. A line. This. And the line in the segment and the ray, actually all of them, could be perpendicular to the segment, but you don't know that for sure. That's coming later. We could have a perpendicular bisector. Right now it's just a bisector. Okay. Any questions at this point? Well, good? All right. Let's do this next example. It says B is the midpoint of line segment AC. All right, so the first thing we do is draw a picture. Here's line segment AC. B is the midpoint. Right? So you always want to do it a little bit at a time, right? And so as I get through, if I finished everything before the comma, like if B is the midpoint of line segment AC, does my picture reflect that part of the sentence? 100%? No. No. What am I missing? Little lines. This tells me that B is the midpoint. Okay? So there you go. Now we have that. Now the length of AB is 5x, and the length of BC is 3x plus 4. I want to find the length of AB, the length of BC, the length of AC. All right, so can I start this just like I did the other ones, where I add the two things together? Why not? So nothing to equal to, right? If I knew the length of AC, if I told you the length of AC is 50, could we work this exactly like we did the rest? Yes, okay. So remember that I'm going to repeat this like a broken record. First step, 0 work, plug it in. That's it. Okay, don't do any work at all, even if it's easy. Because, yes, I could add them together and set, if I knew it was 50, that'd be fine. There'd be absolutely nothing wrong with working it. I would have another option, but that would be fine to do it that way. If you start off and in your mind you're going, okay, well, I'm supposed to add these together. So I'm going to do 5x plus 3x plus 4 equals, and then you're like, well, I don't know AC, but it equals, it equals 8x plus 4, right? Now, is that a true statement? Yeah, it's totally a true statement. There's nothing wrong with this. But when you start to go and try and solve this, that's when things completely cancel out and you're just going in circles and you're getting nowhere, right? See, you did some work right here. It wasn't much. I'm not saying it's hard, but if you remind yourself every time, don't do any work, just plug it all in. So, and then you don't have something to plug in one spot, you can't do it the way you're trying to do it. It may work on another problem, but it's not working on this problem, so we got to find something else to do. So this whole segment addition thing, not working out for us here, right? Because I did some work. Don't do that. Because even if you can work it this way, even if I knew that this was 50, there's still some of you that might do this, and then you just get yourself confused and you're just going in circles. Okay, so I can't add them together. But these two pieces, AB and BC, are what? Congruent. The segments are congruent, therefore their lengths are equal, the same, so they're equal. So does that tell me just by saying that exactly what else to do? Yeah, I can set them equal to each other. Right? So 5x equals 3x plus 4. There will be times, guys, when I say things like that to you, and I'll say, all right, you can tell me, the segments are congruent. What does that mean? Their lengths are equal. But I still don't get it. I don't get to what to write down. Like, you literally just said it. So sometimes you need to listen to yourself. Makes sense? I mean, if you can talk your way through it, you just told yourself what to do. Then it's a piece of cake. So then it's just 2x equals 4 and x equals 2. So it doesn't always have to be crazy hard. You just have to get it set up right. Okay? So x equals 2. Not done, because I got to find all the other stuff. So the length of AB is 5 times 2, which is 10. Remember, even if you think it's dumb, I know 10 is easy. This shows process. That's the length of AB. Then BC is equal to, what do we know it should be? For 10. But again, if I messed up, then this is an easy way to check myself. 3 times 2 plus 4. Oh, well, guess what? That's 10. I'm not surprised, but I'm glad it matches. That's BC. Do I have anything to plug in to get AC? No. But AC is equal to 10 plus 10. There's still something there to write. 20 equals the length of AC. You really only have two options here. You're either adding them together and setting them equal to the whole thing, or you're setting them equal to each other. That's it. Adding them together, setting them equal to anything else, or doing anything else weird with it, none of it makes any sense. Okay? We all good so far? Questions? All right, so I want you to start working on the next one. All right, so I looked at everybody. I glanced at your X. I didn't look at the whole thing necessarily, so I think if your X wasn't right, I think I said something. I don't think I missed any of you. But so D is the midpoint of EF. And then we know that the length of ED is 4x plus 6. DF is 7x minus 9. Okay, so I can't add them together and set them equal to anything because I don't know what EF is. They are congruent, so I can set them equal to each other. So 4x plus 6 equals 7x minus 9. It's going to give me 3x equals 15, so x equals 5. Now, remember this. Listen carefully here. Once you set it up, you're done with the geometry. So if you're missing this stuff and you're frustrated and this is hard, you need to look at what you have and really examine what is difficult. Are you not getting the geometry part of it, or can you not do the algebra that you're supposed to already be an expert at? Okay, so you need to evaluate that once you start getting frustrated, because it's most likely not the geometry. All right, so then I plug it in. The length of ED is equal to 4 times 5 plus 6, so that's 26. Then I got to find the length of DF. That is 7 times 5 minus 9, which is 26, which is what I would expect, but it's an easy way to check yourself without actually making the effort to check yourself. And then you hope that you're right on both of them, because you got to use those to get you EF. 26 plus 26 gives you 52. Okay. Any questions on that? We good? Awesome. Then go ahead and glue that in if you haven't already.